these are the answers for the fact file on alcohols 2.6. Question 1. Which of the following is a tertiary alcohol? So if we look at the names of the compounds, that gives us a clue to begin with. So 2-methyl-butanol, 2-methyl-butan-3ol, pentan-2ol and pentan-3ol. I'm going to rule out the pentan 2 and 3ol straight away because there are no methyl chains, so we know that it's not actually going to be a tertiary alcohol. Tertiary has to have the OH attached to a carbon which is joined to 3 other carbons. That's what we're looking for here. So if we look at A, 2-methyl-butan-2ol, so I've got 1, 2, 3, 4 for the butan, and then 2-methyl, so a methyl group there, and it's a 2ol, so the OH is on the same carbon. So you see there that this carbon with the hydroxyl group on it is attached to 3 other carbons. So the answer here is A. If it had been 2-methyl-butan-3ol, the OH would have been, wrong pen, the OH would have been on here, which would have made it secondary because it would have been joined to just 2 other carbons. Okay, question 2. C4H9OH has 4 isomers, butan-1ol, butan-2ol and 2 others, A and B. So give the IUPAC names of isomers A and B. So let's look at A to begin with. So when we look at A, we've got, let's see, 1, 2, 3 carbons. I'm just starting at the end with the hydroxyl group on it just because it's easier. So we've got 1, 2, 3. If I go this way, just in a different colour, 1, 2, 3 carbons that way. So it looks like the longest chain is 3 carbons, so it's going to be a prop something, and then so propan something all. I have to put the number in still, and then we've got this methyl group as well. So we want the lowest possible total. So I'm going to go 1, 2, 3. So that would make it then 2-methyl propan 1ol. So I'll put it in here so you can see it. 2-methyl propan 1ol. Now looking at B, again I'm going to look at this hydroxyl group here. It's right in the middle, so if I start at this end I've got 1, 2, 3 carbons, or if I start here 1, 2, 3, so it doesn't make any difference really which end I start from. So this is going to be on number 2, and I've got a methyl group which is also on number 2, so this one is going to be longest chain is 3, so it's propan again, and it's a 2-ol, and this time it's 2-methyl. So the 2 there were 2-methyl propan 1-ol for A and 2-methyl propan 2-ol for B. Number 2, part 2, name a reagent you could use to distinguish between isomers A and B. Include any observations that occur when it's reacted with A and B. So 3 marks here. You're going to have to say what the observation is with A and with B to get the full marks. The first mark is for the reagent, which is acidified potassium dichromate. And you must always say, if something is a solution, you have to say it's a solution. Okay, so acidified potassium dichromate solution, 1 mark. If you just said potassium dichromate solution, you wouldn't get it either. You have to include acidified. So then with A, if we remember what A was, it is, there we go, it's a primary alcohol because the hydroxyl group is attached to a carbon which is only attached to one other carbon. In the second one, in B, then there are 3 carbons here attached to that carbon with the hydroxyl group. So with acidified potassium dichromate, it's going to change from orange to green. And that's because oxidation is taking place there. It's a primary alcohol, so it's going to go straight to carboxylic acid if you let it. But with B, there will be no change. It's going to remain orange. B is a tertiary alcohol, so no oxidation possible. Right, B. Butane 1-ol has potential as a biofuel, which is an alternative fuel. Suggest why butane 1-ol can be considered as an alternative fuel. Anything sensible here, really. I suppose because it's renewable. Because it's a clean fuel. Or you could say it's an alternative, it's instead of, you don't want to say alternative because it's the same word again. So instead of a fossil fuel. And that would be like any one of those. Okay, C, write an equation for the reaction of butane 2-ol with phosphorus pentachloride PCl5 and name the organic product. So I'm guessing there would be, excuse me, 1 mark for the name and the 2 marks then for the equation. So it's butane 2-ol. So we've got 4 carbons and the OH is on the second carbon. So sometimes it helps to draw the structure out first before you do it. 2, 3, 4. And I like to just draw it without actually putting in all the hydrogens just because it's quick. And then that lets me see how I'm going to actually write it. So in this case, it's going to be CH3, CH, and then we have the hydroxyl group, so OH in brackets, and then CH2, CH3. And then the reaction says with phosphorus pentachloride, so plus PCl5. And then that's going to give us, so I'm just changing where I have this OH here, I'm going to change that to Cl. So that's going to be CH3, CHCl, and I don't need to put the Cl in brackets because it's just an atom, it's not a group. And then CH2, CH3, and the other products we get then, of course, POCl3 and HCl. So there'd be 2 marks for that. And then naming the product. So if we look back to this, that was butane 2-ol. I have changed this group to a chlorine. So that's going to be, oops. So the name, you see the little molecule here, it's going to be a 2-chloro butane. So 2 for the equation there, and 1 for the name. So number 3, 3-methylpentane 1-ol is an alcohol. Draw the structural formula of 3-methylpentane 1-ol. Nice. So pentane. So we've got 5, 1, 2, 3, 4, 5 carbons. 1-ol. Typically we draw it at this end, so the OH goes there. And then methyl group on the third one, so it's pentane 1-ol. So 1, 2, 3, that's where my methyl group's going to go, so CH3 there. And then when you're drawing it out like this, make sure you do always draw all of the hydrogens on. Quite often if I'm just roughing it out, I will leave the hydrogens out because I know where they go. But in an exam question, you must include them all. So just 1 mark for being able to draw that. Then write an equation for the complete combustion of 3-methylpentane 1-ol. So we'll have to work out what the formula of it is first. And in this case, we're going to just write it as we're going to keep sort of the OH group at the end, so we see that it's an alcohol, but we're going to add all of the carbons together. So I've got 1, 2, 3, 4, 5, 6 carbons. So it's C6. Then I need to count up my hydrogens. So I've got 1, 2, and 3 is 5, 6, 7, 8, 9, 10, 11, 12, 13, and I'm not including these because they're in the OH group. So C6H13 OH. Complete combustion, so plus O2, complete combustion CO2 and H2O. So it's going to be 6 CO2, and then I have a total of 14 hydrogen here, so 7 water, and that on the right hand side then I have 6 times 2 is 12, and 7 is, do the maths, 19 oxygens. So I've already got 1 in here, so that would take me down to 18, so I'm going to need 9 O2 to balance it. So you're going to get 1 mark, I would say, there for writing the equation, and the other mark is going to be for balancing it. And remember, with the combustion of any hydrocarbon, you can, if you need to, use a half in there for oxygen. 3-methyl pentan 1-ol is a primary alcohol. Name one secondary alcohol which is isomeric with 3-methyl pentan 1-ol. So we've drawn the structure of the alcohol in question at the top there. So we're looking for something else which is secondary, which is isomeric with it. So the easiest thing to do here is to consider what would happen if you stuck one of these, like this methyl group here, onto this carbon here instead of that hydrogen. So what that would make it is be 1, 2, 3. So that would be 1, 2, 3, 4, and then if we had a CH3 here instead, and then this here would just be a hydrogen, so get rid of that one. So it's going to be a 2-ol, so 1, 2, 3, 4, 5. So let's see. Yeah. So 1, 2, 3, 4, 5 would be pentan. Oops. And it's 2-ol. And then it's going to be like 4-methyl pentan 2-ol. There are lots of other ones you could go. You could go hexan 2-ol, 3-methyl pentan 2-ol, or anything else that was suitable, really. Okay.